Okay, dentist in a surgery keeps a record of the waiting time of each patient. The waiting times for one Monday are summarised in the table. So I've got 12 for between 0 and 5, 15 between 5 and 10. I've got to calculate an estimate of the mean waiting time. That means I need to add them all up and divide by how many there are. So there are 12 between 0 to 5. So I wouldn't necessarily always write this down, but I'll show you what I'm doing. So there's 12 0 to 5s. There's 12 of those. And there's 15 5 to 10s. A bit more of those, 5 to 10. And there's 15 of those. And I have to add all these up. But I can't add up 0 to 5 and 0 to 5. It doesn't make any sense. So I take the midpoint. And then I say roughly they're the midpoint. And that is why it's an estimate, because I take the midpoint. So I take the midpoint for the first one of 0 and 5, and that's 2.5. Between 5 and 10, it's 7.5. You want to always just check that it is actually correct. Don't just follow the pattern. 20 to 25 is 22.5, and halfway between 25 and 30 is 27.5. And the frequency is f, and the x, the data or the value I call x, and this bit is fx, because I've got 12 2.5s, and 12 times 2.5 is 30, and then I've got to do 15 7.5s, and that's 112.5, and we got 200, and we got 9 17.5s are 157.5, 5 22.5s are 112.5, and finally we got 82.5. And we have to add up all these numbers, so that means I add up all the 2.5s, etc. And the 2.5s come to 30. So I've got to add all those up, and that comes to 695, and divide it by how many there are. Well, there's 12 in this group, there's 50 in this group, so I need to divide by the total frequency, and that adds up to 60. And so the mean is the total, which is 695, divide by how many there are, which is 60, and that equals 11.583. And if I want to give it to one decimal place, 0.5, and next time was an 8, so I rounded up 11.6. Draw a frequency polygon to display the waiting times data. Right, so I've got nothing up this scale here. This is simply the frequency, so it needs to go up to 16. That's nice, so each little square can be worth 1. Like so. You want to start with 0, don't want any discontinuities. So to draw a frequency polygon, it's just like a bar chart where you join a dot from the center of where the bar would be. So the bar for 0 to 5, 12 would go up to here, but we just put a point or cross in the middle of that, and we keep on going. So 5 to 10 is 15, and 10 to 15 is 16, and 15 to 20 is 9, and 20 to 25 is 5, and finally 25 to 30 is 3. And then we have to make a polygon, so that means I need to draw it up with a line. And just keep on drawing the lines, and that's why it's called a polygon, because it looks a bit like a polygon. And that's the first part done. Then we have to write down the modal class, and modal class starts with mo, which reminds me of most. The most common class, it's the 16, were between 10 and 15. So we want to write that class down exactly like that. 10 is less than t, which is less than or equal to 15. Right, so dentists have a target of fewer than 25% of patients waiting more than 15 minutes. Did they meet their targets? And yes or no, and I'll show how I decide. So more than 15 minutes, that could be these ones here. 9, 5 and 3. So 9 plus 5 plus 3, which equals 17 patients more than 15 mins wait. And that's 17 out of 60. So I calculated 17 out of 60, and that will give me 0.2833, which equals 28.3%. Therefore, no, because 28.3% waited more than 15 minutes. The alternative way of doing that, I'll do it in red. The alternative way, you could have said that 25% of 60 is a quarter of 60, so that's 30, that's 15 patients. And then showed that 17 patients was more than the 15 patients. That's another way of doing it. But that's question 2 done.